Okay, so Alison is going to talk about satellites for digitalization of railways. Currently works as a developer and technical architect at CGI in the space sector. The project she's going to tell us about is led by CGI, sponsored by the UK Space Agency and the European Space Agency, and hopes to improve passenger Wi-Fi and operational systems. Improved passenger Wi-Fi is definitely something we can all look forward to. It's an operating grade with it, so it should be interesting.
All right, so hi, so yes, I'm Alison Hopkin with CGI, and talk to you about a project called SODOR. Let's just check this. Still not quite happy. It's all right. Okay, so what is SODOR? So it's a European Space Agency project. Where leading consortium of sorted various different companies. So to try and solve a problem that perhaps many of you have experienced while travelling on a train, and that's trying to make it food or use a mobile device. So clearly it's often the case that you're going to lose connectivity, and on the train it's like situation. Okay, so on this diagram we've got 4G, so that's on the right hand side, and then on the left hand side we've got the satellite coverage. So we can see that the red dots is where the connectivity drops out, and we've got a few orange and yellow where there's some, but it's not great. But you can see the satellite connectivities generally looking really good along that track. A couple of spots where it drops out, so it's not perfect, but it's something that's there that can fill those gaps. Okay, so these are the sort of different companies. We've been working with a number of different rail companies and satellite company. So there's OneWeb to look at what we can produce. We did have a nice successful demonstration on the North Yorks Moors Railway. So that was quite an interesting experiment. More of that later. So overall, the architecture looks a bit like this. So if you imagine this purple rectangle, that's your train. So normally at the moment, you've got your sort of Wi-Fi, and then you've got your terrestrial networks, and then that's going out into the wider network. What we're looking to do is bring in some low Earth orbit satellite networks, other networks. We've got a few additional sensors. So there's a rough line sensor, which I'll talk a bit about later. So that's how bouncy the track is, and that's used to help identify perhaps there's track maintenance issue. So if there's a particular section of track where you get a consistent bounce, perhaps something going on there. So a little bit more investigation is required. So there's that aspect as well as the activity. So the satellite is able to sort of fill in bits, but it's also feeding into a wider cloud solution where we're aggregating the data. We've got an operations and management portal so that we can visualize where the trains are, where they are perhaps within a connectivity plan, and basically work out which bit needs to fill in what. We've got an additional section which is the SatView connectivity planner. So this is where we've done some analysis beforehand to work out satellite is going to be the best one to fill in the gaps. So like which satellite has got visibility of which bit of track. Okay. So this is the North Yorks Moors Railway trial. So it's great to make use of something like this. We ended up with North Yorks Moors Railway because it's got some nice remote sections of track that would be challenging for us in terms of terrestrial connectivity and working out if we could fill in with the satellites. I would point out that this is quite a big rig. If we were integrating things in with properly the actual production side of things, that would be integrating with the normal onboard systems rather than being this huge, great big rig. It's got some great big cabinets on it that's sort of tiny little bit of it's being filled. So this was so that it was easy to sort of stick it on a flatbed truck and just tow it between the different carriages. So yeah, so that went up, down quite a lot. And so you can see people sort of working on the train, trying to simulate their 100 users, and things seem to go well there. Up on the top there, you can see the portal, developed using React and OpenLayers. I'll go on to that a little bit more about that later. But yes, it's a little bit chilly on the train, so you can see some woolly hats, no heating. But yeah, so we've got some good results and very cool weather. So yeah, so there's okay, second downlink with the uplink. So looking at the 15 max available text, so in different situations. Yeah, so worked really well. We have a good part during a meeting, have a live communication between people. Okay, so for the questions, right? We've deployed our data to shared houses. What satellite will be able to see the track. And again, so that's working that out. So we work that out in advance, and we're able to then use that to fill in the various different gaps. So to do that analysis, we used Geodata 360. So Geodata 360 is a CGI product developed using sorted open source bits of software. And that was two formats, one for direct use by the portal, which they look at, and other sort of CSV type formats that we use, for example, in QGIS. Okay, so Geodata 360, say cloud-based platform, sort of very scalable. So it's able to acquire a lot of satellite imagery, and have IoT sensors hooked into it as well, and then users can upload their own data as well. To that, you're able to ingest that, then processing. You can add in your own different workflows and different steps and build up a sort of a more complex workflow. So it's very adaptable, and yeah, and then you're able to then use it to deliver out satellite networks, 5G networks, and so on. So yeah, a little bit more about the technology behind it. So start with got the core platform, and it's switched on the cloud. So we've got AWS and Azure on here. It's not limited to one particular cloud provider. So that's great that you can install it in various different locations depending on what your requirements are. But yeah, it's one of the advantages that it's able to deal with a huge amounts of data and gradually process it through. Okay, so yeah, so we've got containerization. You can do your own data science analytics, customize it in that way. GDAL that we would have used within the connectivity planning, and then got the user experience. So looking up to produce a portal, suited sort of geospatial type applications. So yeah, so there's that. Okay, so the portal was developed using React and OpenLayers. So it connects into custom API written in Java, and some of it got Postgres database backing some of those endpoints. Others come directly from another CGI product, which is Sensor Insights 360. So we're able to put out the information. So yeah, so this is what the portal looks like. Go for a little bit of a closer view. And yeah, so we can see here we've got the satellite connectivity plotted on the map, various locations. On this slide, we've got a nice green things all the way through. And yeah, so that's that. You can specify what time you're looking at, choose which organisation plan you want to select. You can choose the particular route, and you can choose the connectivity plan file. It is also possible to click on one of the points and essentially see which satellite has been selected for that particular point and string of signal, and get the actual specific location out from it. Okay, and then there's also the rough ride events. So, as I spoke about before, this is sensor on the train. We've actually got them at a few different locations within the carriage. So there's one at one end of the carriage, there's one in the centre, and then there's one at the other end of the carriage. And you get slightly different results from different bits of the carriage. And this information is fed back. It does produce quite a lot of information. So we did find that there were lots and lots and lots and lots of points being generated, which meant that we ended up using clustering to display the points. So in this picture, we've got the comfort. So this is the comfort score that's being displayed. We've just selected two categories there, so that's fairly uncomfortable, uncomfortable. What that actually means is real life advice, so that's what I have to say. Yeah, so that's quite interesting. And then it turns out there's an ISO level of comfort and a BSI standard for comfort as well. So yeah, simple stuff. And well, there's even a sickness category too. So kind of hoping that doesn't really come back to. Okay, we've got the very time, so going on.
Very good. Thinking about the sickness level there, side Have you done this with the pending units? I'm remembering the trouble that they had with pending.
Okay, now. So we haven't done any specific tests with those, but there are plans to test it on other railways as well. So that it's more, I guess the rolling stock on the North Railway is fairly old. Which in a way is one useful test because you've got very distinct, more like different results. But yes, there are definitely plans to pilot other railways. Bring it to that railway.
Quite like that. Obviously, because that way they use them like Starlink. How much you love our to the mass. Their coverages.
That's right. So, Starlink is one of the providers that we consider. I think it was it's definitely something that we tried out. I think we found that it wasn't quite sort of at this point reliable enough. So that's why we ended up with the thought and but there is space for providers.
Hi, so then get more about these readings, is it?
So it's okay. So TGI the project. And yeah. Oh, that's very good. I think we've there's all the file theory to get things in like that happen.
How long did it take you to look again?
I was thinking of that. Yes, but it's still a bit of that quite shoehorned into the name.
Okay, thank you very much.